here. Okay, everyone. First off, welcome to the Environmental and Social Impact Lightning Talks at the Data Institute. I first want to get, hopefully, a sound check, make sure everyone can hear me. It looks like it can. And I think I'm getting a positive signal that this is people can hear me. Okay, great. So first off, welcome to the end of the year event for our one of our initiatives here at the Data Institute. I'm David Uminsky. I'm the Executive Director of the Data Institute. The Data Institute, if this is your first event here at the Institute, this is just a bit about what we do. It was established in 2016. And the Data Institute serves as the umbrella organization for all the data science, research, education, and programmatic activities here at the University of San Francisco. It has a 5-point mission, particularly built around the successes and mission of the university as a whole. We love to get outside of the university and partner on exactly projects like you'll see today. That's both with industry, nonprofits, social groups, organizations, civic groups as well, to see how data science can advance the social good of the world. While doing so, and you'll see very great examples of this, is we want to train a highly talented and ethical data scientists. These are students both at the undergraduate, graduate, and professional training area that exit both understanding the state of the art of data science as well as the ethical implications of the work they do. At the core, we're a university and we support data science research. And I'm going to go over 3 of the main research initiatives on the right as well. And really, the main focus of when we think about growing data science as a field is to build an inclusive community of doing so. At the top of our initiatives is our youngest initiative, the Center for Applied Data Ethics, which has very significant interest and overlaps with the current work going on in the environmental and social impact work. And here, the center, led by Rachel Thomas, started in August, and really has a hands-on focus for solving the ethical issues around data science, but particularly the harms that are going on right now. The focus in our case is not so much what's going to happen 50 years from now about automation and AI, but really focusing on the idea that currently data is being used both for positive and negative impacts on the world, and to understand those impacts and how to mitigate and how to address them is the focus of our center here at the university. The middle initiative is our oldest initiative, funded by, and I should say that the Center for Applied Data Ethics was funded by the Newmark Philanthropies, and I'm proud to announce that very recently in this past week that Craig has agreed and the philanthropy group has agreed to fund the 2nd year for the Center for Applied Data Ethics, so we're really excited about that. Our Wicklow AI and Medical Research Initiative is also funded by the Wicklow Foundation, really seeks to develop a new paradigm of medical and AI research that's really at the forefront of both fields, as well as understanding a new way to efficiently collaborate on problems that can otherwise be very if you were lucky to join us last week, you saw quite the set of lightning talks around the work that was done at the end of the year kickoff then. But today we're going to talk about the environment and social impact work, and this is largely supported by the 11th Hour, which is a group involved at the Schmidt Family Foundation, and we are really delighted by the support of the foundation to do all the work that you're going to see today and many more things. And to do so, what I really want to do is introduce the person that's really in charge of a great deal of the success of this initiative for this year. It's Daniel Grzenda. He's our current staff data science for this initiative. He's also joined us this past September, I believe, and is an alumni of our program, as well as a passionate scientist looking to use the tools that he's learned to solve many of the problems that you can see today. And I think that I'm very proud that we were able to recruit him, and he's really been fantastic, both on the mentoring side as well as the entrepreneurial side of solving really hard data science problems in the wild. I think, as you'll see, it's not always the case that groups working at the forefront of really important problems have all the resources required to do data science. And I think this has been a really incredible initiative to explore how to do this in a successful way. So without further ado, Daniel, I'd love for you to take it away.
Thank you, David. And hi, everyone. Thanks for coming. Sorry we couldn't do this in person, but I think we've got a nice webinar put together today. So like David said, my name's Daniel Grzenda. I'm the staff data scientist who leads the Environment and Social Impact Initiative here at the Data Institute. And today is really going to be a celebration of all the work that's gone on in the last year with a focus on 3 of the projects that our students have led. And all of the work that you'll see throughout the presentation it's been made possible by the funding from the 11th Hour Project. They make all this work that we're doing and the mentorship we can provide the students possible. So a little bit of background on the 11th Hour Project. They are a grant-making foundation and they serve the nonprofit community. And they're really focused on our future and making sure the systems that we all share, whether that's our community or our environment or even our humanity, making sure that they're shared more equitably in the future than they are today. And they do this by investing in 4 major areas. So there's energy, which is focused on not only renewables, but also on our transition from fossil fuels and monitoring and making sure we do that successfully. There's food and agriculture, which is concerned not only with the farming community and our agricultural land, but also our food systems and how we get the food from our farm to our tables. Then there's human rights, both domestic and abroad. And finally, ocean health and monitoring, which is done through the Schmidt Marine Technology Partners. And so the 11th Hour makes grants to many of these organizations. So they have a large collection of grantees. And these grantees are really, they're in the trenches every day. They're working on all these projects to make sure that they drive this change forward. And because of that, they often lack the bandwidth or technical resources to really take full advantage of data science and software solutions. And so the 11th Hour board, along with the emerging strategies team at the 11th Hour, had this idea that partnership with the Data Institute, the Data Institute might be able to serve as kind of the centralized hub, not only for data science, but some software solutions that can help these grantees to drive forward their mission. And not only that these tools could be used by the grantees, but also that they could affect the wider nonprofit community in individual spaces that they all work in. And so that centralized hub, this is what that centralized hub looks like. It's a collection of both our students as well as some staff researchers. There's a couple postdocs in here. This is now the 2nd year of the initiative, and we've been delighted with all the hard work that these students have put in. So the main way that students contribute to this work is through something called their practicum, which we'll talk a little bit more about later. But other ways we engage with grantees include researchers like our postdocs and faculty doing their own research projects, or our staff consulting on tools and techniques that grantees can use to process data. As well as in the future, we're hoping to identify ways that grantees can work together with data being that shared link between the grantees. Maybe they're working on a resource they both share and we can bring them together through data. And so since today is really focused on our practicum projects, I wanted to give you a little bit more about a little bit more background on our students and the types of projects they engage in. So here at USF, we have a 1-year master's program where students come and they come here and spend a year in San Francisco, and they work really hard to get really good at data science. And so along with their coursework, they also have what we call a practicum project, which is when they go out into the real world and work at an organization where they can get hands-on experience applying data science. And they do this for 9 months, 2 days a week. And so to the right here, you see some of the companies that we have worked with, but it's not just these companies that have, data science isn't just restricted to these companies, and it's not just restricted to big data problems. So we found over the years that there are many different types of data science problems, and there's the opportunity to do these same types of projects with nonprofits. And so that's where our partnership with the 11th Hour comes in. There is this part of the work we do not only achieves a part of the Data Institute's mission that David highlighted earlier, but it also goes a long way in achieving the mission of the greater university, which you can see to the right. And here are just some of the examples of projects you won't hear about today, other than this quick overview. So in the top left, we have Eureka Recycling. And this is a nonprofit organization that handles all the recycling for St. Paul and Minneapolis area in Minnesota. And we worked with the workers you see here on the left, because they have this job that can sometimes take a toll on their bodies as they're sorting through recycling, making sure that the things that get into our recycling streams actually end up recycled. And so we worked with them to identify which positions on the line actually caused the most stress, and developed a optimized worker rotation so that their work didn't take as much of a toll on them and they were still able to do their job. And to the right of that, you also see the recycling trucks at Eureka. And we worked with them as well to develop route optimization last year. And another example of a project in the food and agriculture area is California Farm Link. At the bottom left there, they are a agricultural linking organization. So they make sure that land already a part of the agricultural community stays within that community. And they grant loans as well to farmers in the state of California to make sure they're able to continue farming that land. Green Wave, similarly, in the center there, we're consulting with on developing a platform to teach people to farm our oceans. And we're working with Inclusive Development International on palm oil tracking so that we can understand the deforestation around palm oil and how its supply chain and how it gets into a lot of things we consume every day. And finally, there's the ocean side, and that picture to the right is ocean plastics. And we worked with an organization called Ocean Diagnostics last year where we helped to identify microplastics within the ocean and developed machine learning models that went onto their floating buoys so they could be deployed to the ocean and test and quantify the amount of plastics in our oceans. And so all of this are ways we identified impactful data science that we could do that would still give our students a very technical practicum. But you might think that all those sound very different, and they are. Over the 2 years, we've worked with 10 different grantees across the 5 different areas of the 11th Hour. And the 3 you're going to hear about today from our students are these 3. But before we jump into the projects, I wanted to tell you a little bit about how we meet the grantees where they are. Because these grantees are each in a different place on their journey with data, we try to tailor our help and our service in a way that can meet their needs. And so to do that, being a university, we did what universities do best, and that is to develop a rubric. Here is how we think about our projects with the grantees and the 4 different areas we can help. So in the first one, the data platform optimization, you've heard a little bit about FarmLink already, but that data platform optimization piece of data science, that is really anytime we advise and consult with grantees on the tools they're already using. So in California FarmLink's case, they had many different pieces of technology that they were passing data between, and we consulted with them to consolidate what they already had and establish a single source of truth. And through that, we were able to help them not only trust their data more and make it more useful, but also streamline the way that they work with data. And then the 3 you'll hear about today, first, you'll hear from Jacob, who did work at Accountability Council. And Accountability Council fits into our data collection access type of data science. Here we build systems to collect data that's already out there. Maybe it's on the web or hidden behind the API. We work with grantees to organize that data, collect it, and then make it more accessible, whether that's to the grantee or to the general public. And then you'll hear from FracTracker Alliance, and Vivian, who did work there this year. And she did work, this type of data science is diagnostic and predictive data science. So this is anytime we run custom data analysis. This is your traditional data science. You're investigating cause and effect, or you're just predicting the future, not in a real-time system. And then last, you'll hear from the team at Hohonu, Matt and Ariana, who built an automated real-time platform to ingest marine data from ocean sensors and built a dashboard to kind of show those reports and predictions. And so that's really how we think about the 4 pieces of data science, and that's a sneak peek at the lightning talks that are coming up. And so without further ado, we'll get to those. These are the 3 lightning talks. Just some logistics. There is a box at the bottom right that says Q&A, not the chat box, but the box that says Q&A. The students have all taped recordings so that they can tell you a little bit about their work. And as these recordings are playing, you can enter any questions you may have or you want answered from anybody on the team into that chat box, into the Q&A box. And the student will either get asked that question live, or we will answer it offline. And so up first is Jacob, who did work at Accountability Council. And Jacob comes to us with a background in physics and math from the University of Washington. And right after college, he got into more the business intelligence side at Uber and Tableau. Jacob was really interested in getting back into more the technical side of data science. And we were lucky to have him work with Samer on this project at Accountability Council.
Hi everyone, my name is Jacob Goffin, and I'm really excited to share with all of you today the work that I've done as part of my research fellowship at Accountability Council, which was made possible by the partnership with the 11th Hour Project. So a quick overview of who Accountability Council is. They're a human rights nonprofit, and specifically they work with communities around the world who have been negatively impacted by internationally financed development projects. The picture that you see here below are some of the team members from Accountability Council, as well as one of the communities that they've worked with. And a quick shout out on the far right-hand side is Samer Rabi, who is the research director at Accountability Council and led the projects I worked on during my fellowship. So I thought I would start today's presentation by giving you the short version of the story of the people involved in this picture. And I think by telling that story, it will help you understand, 1, the work that Accountability Council does, and 2, the importance of their work. So some of the people that you see in this picture here are part of a larger community of farmers in Haiti. And unfortunately, their story starts back in 2011 when they and more than 1,000 of their fellow farmers, pretty much without warning, had their land taken from them to make way for the construction of an industrial park in the northeastern part of Haiti. This is a project that's financed by the Inter-American Development Bank, and it has the support of the Haitian government. What's even more outrageous about this story is that not only does this community have their land taken from them, the compensation that they're giving, which is a very small amount of cash, pales in comparison to the value of their land. And so years go by before this community is even able to file a complaint with the bank. And it's only when they file this complaint in partnership with Accountability Council that they're able to put enough pressure on the bank that the bank agrees to more just compensation in the form of new land, job opportunities at the park, and new agricultural equipment. And so the reason I start by telling this story is I think it really highlights the challenge that communities like this one in Haiti face when impacted by these development projects. Put yourself in their shoes for a second. Not only did you have to go up against your own government, you also had to fight against this really powerful institution, the Inter-American Development Bank. And so any help that Accountability Council and similar nonprofits can do to help communities like this one in Haiti during the complaint process and give them a voice during that process is extremely important. Unfortunately, the story in Haiti isn't an isolated incident. Every year, whether it's the construction of a dam, a mine, or some other development project, millions of people are still negatively impacted, and communities around the world are negatively impacted by these development projects. And so there's still a lot of work for Accountability Council and others to do to continue to give a voice to these communities. And so specifically, the team that I was a part of at Accountability Council is the research arm. And the tasks that they've set for themselves, the tasks that they've taken in order to continue to reduce harm and address the harm that still occurs, is to take a data-driven approach. And specifically what they're doing is trying to aggregate information on all these complaints that are occurring around the world. And by aggregating this information, aggregating this data, they're able to, one, better understand the scale of the harm that's occurring in the system, and two, themselves and others are able to learn lessons across the whole system. And so something that had never been built before that they decided to build is a centralized database of all of these complaints and the associated projects that have occurred. And this database powers the Accountability Council, which is an online platform where anybody can access open data on these human rights complaints. So to give you a quick overview of the data that we're talking about, it's more than 1,000 complaints that we've collected across 129 countries from the past 25 years worth of data. And this data can be used in a lot of different ways. It can be used by researchers who want to understand trends in these complaints. Are there particular kinds of development projects that are more likely to cause harm, for example? It could also be used by other nonprofits who are maybe researching specific kinds of cases in order to understand how they can best help a particular community that they're working with. And so really the focus of my fellowship was to improve the quality of the data that we were collecting and to build tools on top of that data. And so the focus of my first project was really all about collecting more data. And specifically, I was focused on pulling documents tied to each complaint. And this is really important because for someone who's researching a specific complaint, it's important to know what documents have been produced at each stage of the complaint process. Unfortunately, all of these documents, all of this data doesn't exist in one place. It's not in one folder where we can easily grab it all at once. And so what might you have done in the past? Well, you might have given this as a manual project to that one intern that you really don't like. But fortunately for us, now we have much better tools available to automate this process. And specifically what we can do is we can write what's called web scraping code. And what web scraping code allows us to do is to automate the process of visiting all of these different institution websites where these documents live, and automate the process of looking for those documents and collecting them into one place. One technical challenge associated with web scraping code in general is that as websites change, and websites change all the time, the code that you write is sometimes prone to breaking. And so a big important part of this process is writing resilient code. And that, along with some of the other challenges, is probably part of the reason why no other organization had gone through the trouble or the effort of collecting all this data before. But once you have written this web scraping code and you've collected it into one place, there's a lot of really important and valuable tools that you can build on top of this data. And so the focus of my second project was to actually build search functionality into our online platform to let all of our users quickly search the text of the more than 4,000 documents that we had collected as part of this web scraping code process. So for example, imagine that you're a researcher who wants to find evidence of complaints that involve child labor. In the past, this might have been a very manual process for you. You would have had to find the documents yourself, and then you would have had to search passages of text to find the specific places that reference child labor. And now with this tool, we can do all of that for you. So you can quickly get relevant search results that are going to help you with your research and help you with your analysis. And I think that quick use case really highlights why I'm particularly proud of this project. And I think it speaks more broadly to the whole purpose and the mission of the research team at Accountability Council. And that's to build meaningful tools on top of this human rights complaint data in order to help others better understand the landscape of these complaints. And then the hope is whether it's Accountability Council, researchers, or others, they can use that complaint data to better combat harm that still occurs in the system. And so I just want to quickly wrap up by talking a little bit about the tech stack that we used. And I think what you're seeing here is another reason why I really enjoyed working on these projects. I really got to touch a lot of different technologies and a lot of different parts of the data science pipeline. So we already talked about the process of acquiring data where we wrote code in Python. And then we actually had to do a lot of work to standardize that data that we were collecting, as well as parse the PDF text that we were collecting from those documents. we also had to store those documents somewhere, so we had to upload those to S3. And then with the data that we had collected with the parsed PDF text, we actually had to build a search index that would return the results when someone enters a search query. And so that we built in Elasticsearch. And that search index that we built then went behind the scenes to power our Django web application, which the whole Accountability Council platform is built on top of. So I also got to do some front-end development work, which was really cool. And so I think really this whole project was great because I got to touch all of these different pieces. And it was also great because I think it truly was an interdisciplinary opportunity. And I think it's really important for data science students in general to see all the ways in which they can use their technical skills to do something meaningful. And I really think I did find that at Accountability Council. So with that, I just want to give a big thanks to Samer and the whole team at Accountability Council. Thanks to University of San Francisco and the 11th Hour Project for making this fellowship happen. Thank you.
It was really good, actually. And so, Jacob, thank you so much. And I've got great news. There is questions rolling in. So I'm going to moderate some of these questions. We have a little bit of time between each presentation. So I'm just going to start right off, Jacob, if you could answer a couple of these. So the first one is parsing PDFs is notoriously difficult. What tools did you use or do you plan to develop?
I agree, it is difficult. So we ended up using a couple of different libraries. Basically, if one failed, we would rely on a different one as a backup. But the main library that we ended up using was PDF to text in Python. And when we looked at how much text we were able to grab from the different documents, we were able to grab text from about 90% of them. So not all of the documents, but about 90%, which we thought was a pretty good success rate.
Yeah, that's actually higher than I was expecting too. That's great work. So a second question also came in around language, right? So a lot of the complaints and a lot of the focus of the work is actually international. Is there any concerns around the language and the fact that it's not all in English, and what kind of tools can you use to help bridge that gap of a different language other than English?
Yeah, this is a really good question, and it's not just for the document search. I think it's a question that Accountability Council thinks about more broadly for anyone accessing the platform, because people that are involved in these human rights complaints aren't just coming from English-speaking countries. I think for the first version, our document search was just focused on English text, but because basically any Unicode characters that you can put into the search text will match up against the search index, I think there is some work that we can do to make it compatible with other languages, but it's not something that we did right off the bat.
Great, thanks. I know it's always good to hear that there's still more work to be done so that future students can be as inspired in the work as you are. So Jacob, I have a couple more questions. I do want to add though that there's a very nice comment, and I would also like to add that we're honored that Wendy Schmidt was able to join and watch this presentation. And she would just like to mention that you've done a great job, Jacob. My last question on this, and then I think we'll be able to transition to the next one, is exactly that sort of extended partnership. So have you identified other groups, either through Accountability Council or others, that may be really sort of excited to engage with a tool like this?
That's a good question. I think we're still identifying, who our user base is. This document search tool just went live about a month ago, but I think it could be really useful, especially in an academic setting, since we're searching through all these document texts. I think that's one strong use case that we've identified is for people at universities to be able to use this tool in support of their research.
Great, thank you. All right, so with that, I want to thank you again, Jacob, and hand it over back to Daniel.
Thanks, David. And good job, Jacob, I agree. Next up, we have FracTracker Alliance. And this was work done by Vivian Chu, who has some past experience, came to us with past experience in the finance industry, and really was looking to get our master's in data science to kind of shift gears into machine learning and work on larger data sets. That background knowledge, though, turned out to be really helpful because she found her way back into a finance-focused practicum project. And so she will tell you about her work monitoring California oil and gas along with FracTracker.
Hi everyone, this is Vivian. Today I'm going to present the 11th hour project I currently work with FracTracker aliens. The 11th hour project are supported by Schmidt Family Foundation and aim to address issues impacting the health of our planet in energy, food, agriculture, and human rights. We're going to cover the introduction and background, a case study telling the impact, and the objectives and challenges in this project. First, let me introduce FracTracker Aliens. FracTracker Aliens is a non-profit organization who share maps, images, data, and analysis related to the oil and gas industry. Their goal is to, by sharing this data, to better inform public and help people to make wise decisions regarding world's energy future. And then, in order to get better understanding the project, I would like to spend several minutes to talk about a little bit background knowledge and important jargons in the oil and gas industry. Please look at the picture on the left side. In the picture, you can see under the ground level, wells are located in different pools. Within a pool, there are different types of wells. In this plot, the blue one labeled as injection wells, the orange one labeled as production wells. How we get crude oil pumped up is that we injected air or gas into the injection wells and increase the pressure in the pipeline to pump crude oil through the production wells pipeline. On the right side, there are important jargons that we need to know as well. Idle wells means wells are not in use for production, injection, or any other activities, but also have not been permanently filled. Therefore, idle wells would be identified as bad assets for operator in this industry. Abandoned wells is wells that are no longer in the production phase, but have been permanently sold by the operator. FracTracker discovered that designating a well as idle is the temporary solution for operators, but comes a great economic and environmental cost to California. A simple equation defines the problem is that idle wells plus unplugged wells could cause economic and environmental costs and further threaten public health. What FracTracker's mission here is to investigating the industry operators to make sure they're shutting down and properly abandon those wells. And what our mission here is to facilitate FracTracker by exploring oil industry data sets and modeling data at a more granular level. Let's start with a case study. California Resource Corporation, also known as CRC, is established in 2014. Originally a subsidiary company spun off by Occidental Petroleum Corporation. According to the record, they own 245,000 wells. Among them, 3,700 wells are idle wells. Looking into their annual report, their revenue stream incurred a significantly declining trend, and their stock performance are really poor in recent years. So the potential question we want to ask here is whether Occidental spin off healthy wells or orphan wells to CRC. Is CRC's financial status as solid as it appeared on their annual report? The major challenges are in the data cleaning process. For the wells data set, I have to pull out data from Access database. The data set are pretty huge and we have to join all three together with the same ID exists in all three data sets. After joining the data sets together, we need to impute missing values. Therefore, I need to separate features into either categorical or numerical. And using the mode for categorical features and mean for numerical features. While complete the missing value imputation is not the end. We have another obstacle with API number standardization. API number is the unique identification number for each well. The standardized API number should contain 10 digits. However, the dataset we got an API number with 6 digits to 12 digits. The API number are either missing the front or the end part. Therefore, we separate the API number by number of digits and match pattern for each group. For the permit dataset, we need to web scraping all PDF from the website and convert over 1,000 PDF to CSV files. It was really hard for those 1990s PDF because the low resolutions, there might incur loss of information in the process.
Oh, no, sorry.
And the only solution is to check back and manually fill those cells. After convert all PDF to CSV, we need to match column name for each CSV and then vertically stack all of them together to one huge data set. After finishing the data cleaning process, we're now ready to do pattern discovery by aggregating data sets on different levels. Now let's look at what we get for CRC. First, we're doing revenue analysis given the production and injection data of CRC. Since we don't actually have the real-time price data, therefore we use WTI crude oil index as a proxy. And we sum up all CRC's wells production and injection and plot it along time. The x-axis here denotes the date. The y-axis of the upper plot denotes the revenue amount generated by CRC. And the y-axis of the lower plot denotes the injection amount generated by CRC. The red dashed line is the benchmark for 2014. And the blue line in the upper plot denoted the revenue that reported by CRC. We can clearly see that the revenue trend has a clearly dropped after 2014, and there is a gap between the revenue proxy and what they actually report. And when you compare the upper plot and lower plot together, we could see a pattern that they try to pump more and more water or gas into the pipe. Whereas we're guessing here is that operators try to increase the pressure and get more oil pump out from the well. In order to do a further analysis on the stage of CRC's wells life cycle and the overall financial health of the company, we generate a plot that compares per well's production or injection amount with active wells number count each year. The axis on the left denoted the production per well or injection per well. The green axis on the right denoted the active wells number. From this plot, we could see that the per well production are keep declining, while the per well injection are slightly increasing, which give us a signal that the well is not profitable anymore. But CRC trying to increase their total production amount by injecting more water or gas into the pipeline to increase pressure and drilling more new wells. In conclusion, by gauging into data sets, we could see a decline in wells revenue generation ability in California oil and gas industry, and a general trend of increase in injection amount, which could imply that operators try to pump out more oil by injecting more water or gas into the well to increase pressure. And the kept increasing active wells count number also give credit to it. Another possible explanation is that since the plug-in wells fee are expensive enough, that operator keep orphan wells as idle wells instead of plug those wells. What could be going on in the whole industry is what we saw in CRC. So we need to take immediate action to prevent oil operators to drilling more wells and let the operators to plug those idle wells. The future work could be classified into 3 stages. First, investigate whether California's fossil fuel industry are in a declining stage. Second, prove oil operators are carrying idle wells without plugging them because of the cost. The third stage is to increase transparency of the oil and gas industry's practices. Thanks for listening, and also a special thanks to Cal, who got me through this project and let me know a lot of knowledge about oil and gas industry. Then thanks to 11th Hour for their generous scholarship being offered to us. Finally, thanks to the Data Science program, who provides a lot of interesting practicum opportunities for the cohort.
That was a really great presentation, and it looks like you had to take quite a deep dive into this data set to uncover these kinds of results. You know, from first listening, I think that this is really something that is more of like maybe a tip of the spear kind of issue. And you know, do you have a sense, maybe in the conversation you've had with Kyle, how many companies like this do they sort of suspect this type of behavior going on, either in California or elsewhere?
I think
there might be, because we have the inherent in CRC, it might going to apply to all the California oil and gas industry. So we're guessing that it was a trend. So probably that this is a like hidden bomb that we need to discover in the next step.
Yeah, absolutely. And, is there types of channels that you would normally take this type of research towards to begin to affect change at that level?
Sorry, I missed the last part.
Yeah, so, my question is with sort of this, fairly conclusive bit of data investigation, is there certain channels that, FracTracker and your team can sort of take this type of reporting to begin to affect change?
Yes, because as far as I know, that Cal has already sent a report to the government that bring up this issue, and probably FracTracker is like still going to work on the next like thorough report and bring this up to the government in the end. But there is a like brief agenda that already being sent to the government.
So one comment too that I just got as well is, what do you think about capping companies by the number of wells they have at a certain point? So again, I think you allude to this, so they can't create new wells until they closed, another one down.
I don't think there is a certain regulations that saying they can't create new wells until they close down another. But that is a great point. If we can like put a regulation like this to force the company to shut down those idle wells, and then if you want to, you can bring up a new well. I think this is a great way to stop this situation and help to protect the environment.
Great, thank you, Vivian. And just wanted to end with a nice comment from Wendy again that, this is really an important new way for people to investigate the operations of oil and gas. And I really do think it'll not only have a big impact in California, but, probably nationwide. So with that though, and with that final comment, I think we're going to transition to our last speaker, Daniel.
Yeah, so up at the end, we have the team. So 2 students who worked at Hohonu. And the team is made up of Matt and Ariana. And so Matt comes to us with a strong background in math and has used his time at the Data Institute to build many different ML models for many different projects. And Ariana also comes to us with a math and statistics background, but she had some experience working on solar and energy data as well. And her favorite part of this project has been working on the data visualizations. So they're going to tell you about their work working on ocean sensing at Hohonu.
Hello, everyone. Thanks for joining us. We're glad you could be here today. My partner, Ariana, and I are excited to present to you our work at Hohonu, building pipelines and platforms for remote marine data. And before we begin, we'd like to give a big thank you to the 11th Hour Project for all of their generous support and funding, which makes projects like ours possible. So what exactly is Hohonu? Hohonu is an early stage startup based in Hawaii that manufactures low-cost and reliable tidal sensors. You can see a photo on your left of an early sensor prototype. And the way these sensors work is they're placed at a fixed height above the water, usually on a dock or a bridge, and they just ping the water below in order to measure the distance from the sensor to the water surface, and that's how they measure the water level at that location. This particular sensor was deployed at Heia Fish Pond in Hawaii, just off the coast of Oahu. The second aspect of Hohonu is the data science aspect, and that's the part that we're most excited to talk to you about today. Our mission as data scientists is to take this raw tidal data and pre-process it to present it in a clean way to our users, as well as present our users reliable and accurate tidal forecasts for every sensor that they have. And before we jump into the meat of the data science, we want to give you an overview of how data flows through our pipe. The first and most fundamental component is, of course, the tidal sensors. These sensors are streaming raw data continuously, which is uploaded to Hohonu's internal company servers. That data is made accessible to us at the Data Institute via public web API. We query the data and do all of our pre-processing in Python, as well as our time series forecasts. we save the clean data and forecasts to an Amazon S3 bucket. From there, we are able to load that data into a Postgres database running on Amazon RDS, which serves as the backend for our web application. Our web application is based on the Django framework. We deploy it inside a Docker container, which runs on an Amazon EC2 instance. So what does all of this give you? All of this gives you a comprehensive dashboard of title readings and forecasts. You can see a snapshot of that dashboard before you. This particular plot is of the water level at Heia Fish Pond, which you saw a couple of slides ago, and it has 3 different components. In the dark blue on the left, you can see the tidal level at that location as recorded by a Hohonu sensor. And on the right, in the light blue, you can see a forecast generated by our time series models for the first few days of June. And on the left in orange, you can see our historical forecasts. And we always save our historical forecasts in order to judge how accurate our forecasts are. And that accuracy is summarized in the table to your right. It shows the average prediction error for the 1-day, 3-day, and 5-day forecast. And the way you would use this is if I wanted to use the forecast for, say, June 1st, and I was only interested in the 1-day forecast, I would look at the table and see that the average prediction error is 17 millimeters or thereabouts. So I could be confident that for the 1st of June, our forecast, the Hohonu forecast, is off at any given time by at most 17 millimeters.
So now that you know a little bit about what Hohonu provides in terms of tidal predictions, you may be wondering, well, who does this actually benefit? According to the National Oceanic and Atmospheric Administration, about 40% of the nation's total population lives along the coastal community. So with climate change causing sea levels to rise, what we have here, we now have that during high tides, these tides are extending further and further inland. And this is a problem that we expect to be happening more often as we progress into the future. And this image here is just an example of what this tidal flooding looks like in these communities. So with the Hohonu tidal predictions, we now have an early warning system for the governments that monitor these communities so that they can better prepare and alert the people that they care for. And you also have the other individuals like the Hawaii fish pond farmers and other businesses that rely on harvesting fish for a living. They also pay close attention to when the next high and low tides occur, so they know when to go out and cast out their nets. And lastly, the group that could benefit from this is the research community, the community that is actively monitoring how exactly these aquatic systems are changing due to climate change. They can now purchase one of these sensors, take a look at the data and the predictions that we provide so that they can further extend the research in this area.
Some of you may be familiar with NOAA, the National Oceanographic and Atmospheric Administration, and be thinking to yourself, Hohonu is a bit similar to NOAA. I mean, they both provide tidal readings and forecasts for a variety of locations. So how exactly is Hohonu different? Well, there are 2 main components, one hardware and one data science component. On the hardware side, our sensors are much cheaper, an order of magnitude cheaper than NOAA sensors. You can see on the photo on your left in the red box is a latest generation Hohonu sensor. You can see it's very small enough to hold in one hand, and most importantly, it's easy to install. If I could install it, you could install it and be done within an hour. In that same photo in the background, you can see the tall tower is a NOAA sensor, and you can see it's much more industrial in scale. As a result, it's more expensive. So why do we care about manufacturing low-cost tidal sensors? Well, low-cost sensors make coastal coverage possible at an unprecedented scale. For example, South Carolina could place, for the price of having one NOAA tide gauge in that one location, could place a Hohonu sensor every 18 miles along their coast. The second part in which we differ is our data science model. So we use a VAR model for our time series model to generate our predictions for every tidal location at which a sensor is deployed. And we have found that over all of 2019, our forecasts are on average 40% more accurate than NOAA's forecasts. And the plot on the left just shows you an illustration of that. The plot on the right is a little bit more interesting, and I want to unpack it for you. It shows the distribution of errors for both the Hohonu forecasts in light red and the NOAA forecasts in light blue over all of 2019. So it's just a histogram of the error, and the x-axis is the error in millimeters, and the y-axis is just how many times that error has been observed over all of 2019. And you can see they have two different shapes. So let's start with the Hohonu shape. It has the shape of an exponential distribution. And if you don't know what that means, don't worry. I just want you to think about waiting for a bus. If you were to sit across from a bus stop and just with a pen in hand record how long every person has to wait for the bus, you would realize that the waiting times sort of follow this exponentially decreasing shape, because most people don't have to wait that long for a bus, although there are a few people that have to wait a long time, and it always feels like you're that one person. On the other hand, if you look at NOAA's distribution, you see it follows a much more traditional normal distribution, a bell curve, and the errors are much spread out and cover a larger scale. So for Hohonu, you can see most of the error bars are very close from 0 to 50, just like maybe waiting for a bus would be from 0 to 5 minutes. So this just means at any given time, you're more likely to observe a Hohonu error that's between 0 and 50 millimeters than something greater than 50 millimeters. NOAA's observations, on the other hand, those errors are very over a larger range, and the mean is somewhere probably around 70, 75 millimeters. But also, you can see errors up to going as far out as 250 millimeters, although they're not as likely.
Now you're probably wondering, how is it that you're able to achieve more accurate predictions in NOAA? And that's because of two things. One, we use an entirely different model. More specifically, we use a vector autoregressive multivariate time series model. Two, we form what we call sensor communities. What we mean by communities here, we just mean grouping sensors together based off of similar tidal patterns. In this example that we see here, this is a community for sensor 46. And as you might have guessed by now, this purple line here, this sensor wouldn't belong to the community for sensor 46, but these would. So when we want to make future tidal level predictions for sensor 46, not only would we feed it its own data, but we would also feed it the data of all the sensors that belong to the community for sensor 46. In the previous slides, we saw that these low-cost sensors actually have the ability to make very accurate predictions. A big part of that was also due to us identifying anomalies in the data and then imputing them right before we make our predictions. And before we can do all that, we started off with one question. Can we distinguish hardware anomalies from anomalous weather events? The first step into answering this question for us was being able to create a system that would automatically detect data as it's coming in and tell us whether it's anomalous or not. Right now, our system can identify both the hardware and natural anomalies. More specifically, the hardware can be broken up into two kinds, one being the flat line and the other being the random spikes that we noticed in the data. For example, the flat lines can happen for different reasons. It can happen when a sensor becomes decalibrated, or like other sensors that Hohonu also provides that go in the water. Over time, these sensors will develop algae and then slowly flatline, indicating that they need to be clean. The other anomalies that we're very proud to say that we're able to capture are these storms and tsunamis. Although tsunamis don't happen very often, but in 2018, this mini tsunami happened here in Hawaii, and we were able to capture it. Some future directions that we have is, now that we have this system in place that can automatically detect and tell us whether data is anomalous or not, we need to be able to say then, okay, this data that we see here is a hardware-induced anomaly, and this other data that we see here is actually a storm that's occurring. So being able to classify and distinguish between the two. The other thing that we were thinking about was incorporating new variables into our models. Hohonu also captures information like wind, temperature, salinity. So we hope by incorporating these new variables into our models that it would give it a better sense as to how the environment was like when this water level was recorded. And before we end our talk, I just want to say a big thank you to the 11th Hour Project, the Data Institute, for allowing Matt and I to work on this very environmentally impactful project. And we also want to say thank you to Daniel Grzenda at the Data Institute, Brian Glazer, and Stanley Leo at Hohonu. Thank you.
Thank you so much, team. That was impressive. I want to just remark briefly that this is the second year we've been working with the team at Hohonu, and I was very, very involved in the first year, and to watch how incredible the progress you've made on this project, to be able to, essentially far surpass what is currently be done by the regulatory and government bodies is really incredible, and I think it speaks to the innovation in the future of doing work like this. You have a number of really positive comments in the chats, but I want to just bring a couple questions to the forefront as we wrap up. First, a technical question, less around error and more about confidence. So specifically, was there any consideration given to how confident your forecasts were, i.e. your forecast is 99% certain that one day from now it's going to be between X and Y. So really a statement on confidence intervals for your work. And I'll hand that to either of you who want to take it. Yep.
Yeah, that's a great question. Thanks for asking. So we do our time series models in Python, but it actually queries a model in R, which uses the var package. And that package returns the 95% confidence interval, which we have stored, but we haven't quite incorporated it into our dashboard plots. We also have a different kind of confidence interval that is based on our sensor communities, which we're working on implementing soon. And all that does is for a given sensor, it looks at the nearest neighbors in its community, and it sort of just measures the distance. And if that distance is too far, if a node is too far from the rest of its nodes in its community, we might report that the prediction is off, or we're not as confident about that. But that's a really good question, something we plan to implement.
Thanks, Matt. And I have a follow-up question on modeling here, not quite as related. So, there's obviously a lot of techniques to doing time series forecasting and anomaly detection. It's noted, CNNs, RNNs, even the profit algorithm from Facebook is being used a lot. How did you guys decide on using the technique you used for your project? Maybe Ariana.
Yeah. So our main focus was, now that we had like a lot of these sensors deployed across Hawaii, we wanted to utilize this fact. And once we built the sensor communities, we had more than like 5 different sensors assigned to each community. And more specifically, we were in search of like multivariate time series models. So that was one part. And the other part is why we chose this more traditional time series path, was because the behavior that these sensors have, it's very seasonal and it kind of repeats very often. So we thought that this would work just fine. But there's definitely other things that we can look into, other models.
Okay.
Yeah, I'd also just like to add that that's a great question. We sort of use these multivariate models, as Ariana said, as our baseline. This is the second year the Data Institute has been working with Hohonu, but that's a really good direction that future years might consider.
Well, thank you both. And again, I'd like to just end with a very nice comment as well that, from Wendy, that Matt and Ariana, I know that the Glazer team, in fact, has been thrilled with this progress. And, I think there's a lot of incredible things you're unlocking for not just Hohonu, but the sensor community in general, and answering really hard problems that matter, particularly with our ocean health. And with that, I want to wrap the student portion of this and really hand back to Daniel Grzenda to wrap up.
Thanks, David. And to wrap up, I just want to echo all those thank yous. So thank you to both Wendy and the 11th Hour for all the support, to Nagin and Rebecca and Grace on the Emerging Strategies team for helping us identify the best ways that we can have impact with these grantees. And then thank you to the 4 students for all your hard work this year. I know I know this has been a lot of hard work, and we can see the results now. And then to wrap up, I'd just like to say, if you want to learn more, if you work in a space that's similar to this, or you just like more information, my email's there, and I'm happy to talk about this all day. So with that, I think we will wrap up.
All right. Well, thank you, Daniel. And thank you for all your hard work.